Greetings, Josh here, here to talk a little bit more about my 3D scanner project, and along with that, a few other discussions here. It was recently featured on Hackaday, and it was a wonderful experience for me. It happened at 9 a.m., and it was completely unexpected as my phone started ringing off the hook due to so many massive emails. But then again, absolutely awesome. But, of course, during every internet community, there are people who have great ideas and have had some wonderful feedback. Then there are the trolls. I looked at the trolls and I was told to be careful on how I interpret them and don't let them get to me. But, that's how it works. Any online community, you end up with trolls. However, there was a great point that was made about my project. My bill of materials. My bill of materials, yes, it had $2.73 spent on this project by itself. However, I also have an Arduino, I have a laser module, a motor module. I mean, I have a lot of things in there that you could actually put a fairly decent price tag on. And just as a ballpark guesstimate, I would guess around $50 to $100 total for everything together. However, a lot of my parts I said I reclaimed and I got out of broken machines and such. And this video is actually going to be talking about bill of materials reduction in terms of recycling and reuse. I'm over here at Blooming Labs, the Indiana's first hackerspace here in Bloomington, Indiana, and we had quite a few spare junker printers and printer scanners. This machine right here is an HP PhotoSmart C3180 all-in-one. Does printer, scanner, copier. I'm pretty sure it does Wi-Fi as well, maybe. Don't know, but there's a great platform here to take stuff apart with. I mean, we have a nice glass platter right here, paper feed motors in here of some sort, and what I'm going to show you is what I do to harvest, recycle, reclaim these kind of machines and others like them to reduce my bills of materials for future projects. I'll get a whole bunch of motors and springs and all sorts of things out of these that I can use later on. And I'm going to show you what I do. Obviously, a teardown is standard internet fare, but I'll show you what I'm looking for in this kind of a project. Okay, so let's get our screwdrivers out. Unfortunately, this one uses some sort of it uses Torx to get into the thing, so that's the right Torx bit. And we'll go quickly. The other thing I do also is I save all my screws. At first, who cares? Why would you want to save screws? Most of my projects have been built using reclaimed screws from all sorts of other projects. What may look like a waste now, most certainly will not be a waste later on when your education and experiences increase by doing this kind of stuff regularly. And of course, trusty flathead for ripping things out. Great. Okay. Now we can also look on here for the type of plastic they're using, because what I like doing is I like recycling from the very ground up. This thing, junk. Well, I don't just throw the whole thing into the junker. I take it apart for whatever I can, scraps of all sorts, and then I proceed to sort plastics, metals, whatever, what have you. So, junk, but not really. It'll be recycled. Okay, and on this side you had a really great view. There's your motor train, there's your gears, there's all the yummies right there we can work with. Okay. And also I'm trying to avoid breaking the glass platter because, well, that bit's gonna be hard to get into. I'm going to work hard on not breaking the glass platter, because we can use that for a print bed for a 3D printer. Of course, glass ones, you obviously want to use borosilicate, but free glass platter works great. Okay. And by the way, I understand why people use Torx screws for these kind of projects. Doesn't mean I don't like them. Okay. Well, let's do this front cover down. And a lot of times they will hide screws underneath, stickers and things too. So that always makes it an extra problem to figure out where the mount points are at. Ah, there are some more. Obviously, if you can go with not Hewlett-Packard, it'll make your life a little bit easier. But, this is what we got, and this is what we use. Okay, as we see here, these buttons aren't really real. They just articulate actual switches behind them. So this is more wonderful junk plastic we can go ahead and throw into the recycling bin. Now what we have over here is a nice button harness and LEDs and such over here. I want to try to take these out safely so that we don't ruin them. These are nice little pre-done boards that we don't have to go build. They're great. Okay. We got the upper part done. And now I'm seeing leaking of the ink cartridges. Oh well. We don't want to bend too far back because there's also a LED harness in here. An LED, or for the scanner, and those things are awesome. Those things are what I plan to use for the white light for the color side scanning of my 3D scanner. So if you get a hold of one of these, awesome, use it. It'll usually have a 12-volt regulator for those tubes. Not sure quite how they work, not really got into that, because everything I've always got has been pre-made and done. Okay, as you see, we safely remove that board. Looks like this is where the micro switches are. We'll go ahead and take this apart right now. And then we can go ahead and put this on the side. More plastic trash. Sometimes these glass panes are kept in by plastic retainers, like this sometimes. Sometimes they are kept in by plastic retainers and or glue. The glue ones stink. They are worth it if you use like Goo Gone or something like that, or acetone. If you use acetone, please wear goggles. Don't be stupid and get the acetone splash in your eye. Great way to lose your vision. Oh wow, this is a nice little module here. As we see, we have an optical encoder, or I forget what the name of those. We have an optical encoder where you break it and it sends out a 0 or a 1. Nice little wiring harness. And we also have this nice display and a whole bunch of extra buttons. This isn't really much about electronics right now, although we're going to save all this stuff. So this goes over here in this bin. Now let's see if we can harvest this glass pane. Let's see if that clip was the only thing keeping it in. And another piece just fell out. Another little plastic junk. And looks like that's just, and there we go. Nicely came out, really nicely. So we have more plastic junk. Let's go ahead and get our plastic junk all together. Okay. Lots of plastic junk in these things. Okay, so now we have a nice glass pane. Not sure how big it is. I'm guessing about, looks like a 9 by 12 roughly. It fits in a standard 8.5 by 11, so a little bit more on that. But this is a perfect thing for a 3D printing bed, where you can print on this glass directly. And fortunately, it looks like this is treated glass, so if you don't cut it, otherwise the whole thing will shatter safely and go into little bottles. Okay, what do we have next here? Okay, there's a wiring harness over here I just disconnected. Looks like there's a few things actually. First off, there's this little, real simple switchboard right here for the power button. On a nice little wiring harness. Goes with the electronics bin. Then we have this wonderful assembly right here. This is gold mine worth of stuff. Now, as we see here, we have a whole big gear assembly. I want to take a look at this later on, but right now we're just going to keep it safe. As you see, there's a light right there. There's a worm drive right there, and it creeps along. And on the back side, we have a huge ferrite band cleaning up the signals that go in and out of this harness. However, we have to go ahead and remove this safely, so we want to, well, safely as I can. Okay, and we can remove this nice ferrite core. We can use in plenty of other projects for isolation. And there's more plastic junk. Okay, and we have this really cool assembly right here that we could easily hack and make around and work around. It looks like there's an optical encoder for counting how much this thing turns. I mean, this thing is a pretty nice little harness. And I'm guessing when you look at the lines here, there's 5 traces on this side and a bunch of traces on this side. I bet you this is the motor control side and power. This is data. So cool, that's a later on thing. Nice circuit so far. What we're going for is motors. So, more plastic junk. Big surprise. Gotta love American construction. I'm sorry, Chinese construction. Everything seems to be plastic. Okay. Well, what we have here is a really nice thing. If you look right here, there's this nice belt system right here that we're going to get. This thing is what I use in my projects, along with one of the motors like this. Although I went with a stepper and not a regular DC motor. We're not quite sure what this one is yet, so we still got to tear down a little bit further. There's a linear optical encoder that goes along here. I'm guessing by taking apart previous printers, and it's just stretched across here. I'm not sure how to use it, but I know it's useful. Let's go ahead and get some more of these screws out here. And darn these allergies. Okay, so take this out. Okay, so what we have here is we have a paper feeder. These little paper grabbers. They aren't hooked up to any motors, they're just on little spindle wheels. And this is quite a nice little bit of metal, so we can go ahead and pop this plastic thing off here and put the metal to the recycling on the metal side. And probably what I'll do, because I don't have any other better use for this yet. Okay. What else do we have here? More screws. And be prepared that when we get down to the actual cartridge assembly and the ink squirting stuff, it can be rather messy. So just be careful and be prepared for this kind of yuck. Currently I'm over at this hackerspace, so if we get a little bit of ink or whatever on a table or whatever, I'm not too terribly worried. Don't do this on your dining table. You know, that would not be a good idea. Okay. Now I'm seeing here as well, I move this cartridge out of the way. I'll go ahead and pop this out. Okay, more metal trash this time. There's the optical linear rod. Really, really fine. It looks like it's just, grayish. It's actually a whole bunch of vertical stripes. We'll put this over here because I'm sure we'll have some use for it. Not yet. Okay, I'm seeing on the actual printing harness. We're going to go ahead and, well, if I can, without breaking it, they have this part in here. There. They have that in there really securely. Oh well, we'll come to that in a little bit. What I'm seeing over here on this this system here, there's a pulley on the end for tensioning for this belt. We can go ahead and get this. Watch out when you do this so it doesn't recoil. There looks like a fairly hefty spring in there. Okay. Well, we'll come to that in a second here. What needs to be done next? Just pretty much look for more screws and unscrew them. That's the name of this game here. And watch out for this pit over here. Usually on one side it's a head cleaning, and what it is, it's usually a cotton or linen batting, and it just squirts all sorts of ink in those things. So be very careful and notice where that is. Okay, cartridge. Other cartridge that was leaking. Yep. Okay. What do we got next? Okay, we're going to get over this electronics board here. It looks like this is also where some of the gears are hooked up to. Okay. Can we remove this? Not yet. More screws. And I'm not going to edit this video because this is a real-time teardown and how long it takes you to process a individual piece. Nice DC motor there. Okay, so it's DC that runs this thing, and they use an optical encoder for feedback. That used to be what the RepRap project used to do a long, long time ago on their very first model. But they've gone to using proper stepper motors instead, so that you don't need to have the feedback mechanism. You can have your in stops, and that's all the feedback you need. And I had to change bits because they use a smaller version of the Torx bit. And what we now have, really nice DC motor. Not sure how fast it goes, but easy to figure that one out. Has a nice header for it, and even a ferrite bead to stop some RF coming through it. Nice, and it's also already got a pulley on it for this specific belt. Awesome, 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 awesome. So we have this piece. Where's where the belt is. We want this belt. We want to take this whole thing apart because this is useful. These screws, by the way, we can go put real standard screws on there. I hate Torx, although they have their purpose. They are annoying to work with. So what else do we have here? Okay, so we have this shaft here, which is an awesome shaft. we're going to go ahead and take it apart. Part of our mechanics. This would be great for a small CNC machine or other type of linear based, CNC, board mill, you name it. And we're also going to keep all the springs as well, all mechanicals. And then on here, it's a regular little, turn my monitor back on, got a little band clip, I forget what they're called, but we can slide this little guy out. Keep it, because it's useful. Take this rod out. Probably check the other side for the clip. Yep, there's another clip and another spring as well. And keep all your mechanicals. They are useful, or they will be useful, and you don't have to go to the hardware store and buy them. And the best part is, they're already perfectly fitting your parts. So we've got that clip. We pull this nice rod out. Now as a last finishing touch, those clips that we just pulled off, we put back on. Because we have a nice lubed board, or lubed rod right here. Really nice smooth rod. So, this is a great mechanical piece. Next, we have the rest of this piece that we were working with. Oh, this just falls off now. So we can get underside here and take a look. How does the belt keep being kept on? It looks like there's at least one screw inset into this plastic junk. Let's see if we can easily take this whole thing off. Let's get this thing out of the way first. Flathead. Gotta love a flathead for prying. Okay. And there is the actual piece here. We gotta break it. These are metal retaining clips, so you just gotta bend them just a little bit. And we got another nice ferrite core. Really, another really nice one there. Cool. Have at least 2 ferrite cores. Okay, and now we have this metal junk. Great for recycling, unless you do forge work. If you do forge work, toss that puppy into a forge and recast things. No sense in letting stuff go by and by. If we can't do it right now, keep it. And if you know you have a forge, or will be getting one, even if it's the coffee can forge, you can find that on a lot of YouTube projects there. My saying is, waste not, what not? And especially me being not terribly money endowed, well, the recycling is very, very handy. Nice long ribbon cable. Cool. Fits this assembly. We may end up scrapping the assembly because of ink, but you know, never know. More plastic junk. And there, we got the hold of the 2 screws that are holding down the belt. They're using a fairly similar belt retaining like the rep wrap does. Except it's actually unlike the rep wrap where you have to cut the belt and do it manually. This one actually is a free sitting belt that's been attached downwards. So it means if we can free this, we have a completely free belt we can use in any product we want. As you can see, two more screws, keep them in the screw pile, and the belt and the retaining clip just falls right out. This thing is pretty awesome because this actually is a nice full belt that fits this DC motor. And if we go slow enough on a DC motor, we don't have to use a step-arm motor. We can just use a standard old DC motor with a MOSFET on it. and power it very, very slowly and use an optical encoder or something like this. But this right here allows you to attach the belt to a specific location and then go around. Awesome thing. Probably a little smaller than what we, than we want, but you know, great for a project. Then we have this little board right here. Because of the amount of ink that's in there, I'm gonna go ahead and trash it into the plastic scrap pile. I'm sure it's reclaimable, I'm sure it's usable, but out of the scope of what I want to deal with. Okay, let's get into the next part here. We have this wonderful, and this is a lot of the mechanicals here. And there's also a lot of electronics here too. This is where the intelligence of this whole printer is. So let's go ahead and continue removing more plastic junks. Oh, nice encoder wheel. What they did here is they wanted to monitor how fast the wheel is spinning by putting an optical encoder on here. Now this is, all it is little tiny little ticks along this whole external part of the wheel. And it looks like near the bottom there is a one of the optical interrupters. That when this thing goes by and by, it can tell how many times it revolves around. So that will be pretty cool, although it looks like the board is separate than the gear system. I've seen some of where the gear and the optical encoder is together. Those things are just awesome. Okay. Now the name of the game is find every screw you can and unscrew it. Or lift it out, I guess. Huh, nice. Well, I thought it was going to be that easy, but I guess not. No big deal, though. You can get this retaining clip, metal scrap. Let's go ahead and disconnect this motor from this main board here, the motherboard. Okay, so we actually was able to lift this up. Okay. Sometimes we just use brute force. Not always the best, but you know, when you know you're working with plastic and you aren't putting it back together, well, hey, it works. Not great, but okay, and this piece right here had a little plastic retainer you just spin, and look, this whole fixture comes right out. Awesome, more mechanicals. Okay, so what else can we get quickly? Gotta watch out. Looks like there's another ink reservoir system right here. Looks like this is where the print head sits. And it's fixed in by a little plastic pop rivet kind of thing. Ah, pops right out. Looks like this is meant for setting the print heads. Not sure how useful this is. I'm sure it's got some use somehow, somewhere. And I'm inked up nice well. I'm going to go ahead and put this in the scrap pile for the time being. And let's go ahead and get these gears right here. The gears are the great parts. Sure, and I'm not using the right size of Torx. Change size to something smaller. That fits. Although, in honesty, what I should probably do instead is not even unattach that motor. I'm going to go ahead and remove it from the other side here. There's some plastic junks here. Bye-bye, spring. Well, it's metal, not too terribly worried. Got a little gearing system that I kind of screwed up here. Whoops. I'll go ahead and take that whole gearing system off. This gearing might be useful, but I may have messed it up irreversibly. What I did though, I wanted to get this side. What we can do is this can be mounted somewhere. I'm not sure what this could be used for yet, but this has all the hardware we need. Actually, does it? Yeah, it has all the hardware we need for turning this right here. And if we put an optical interrupter right here to monitor where these lines get cut and stopped, we have a pretty nice, already pre-built solution. How much would this cost to do at a Chinese factory or an American factory? A lot, because this would require unique gearing and all a bunch of assembly and crap. And this is already pre-done for us. This is the kind of stuff I talk about where it's easy to get pre-done already in a printer like this. We just go at it. Okay, what else we got here? Back to the bigger Torx bit. I'm looking in here, and unfortunately, it does not look like this printer has Wi-Fi. Sad, that's a sad thing to hear, because after the recent Hackaday article about reclaiming Wi-Fi boards from printers and then using them as unique USB solutions, I would have loved to have access to them. Whoops. There goes that piece. Well, this is being a rather pain to get into. Retained and clipped down there somehow. More plastic junk. Yip-de-doo. Metal stuff. Then it's bent. My forcing it bent it. Oh well. It looks like there's no daughter boards. It looks like it's just a one board. Okay. Got it finally out. So after looking at it a little bit here, what do we got? This is pretty much the whole motherboard right here. Nice capacitors. We got a 221, I'm guessing millihenry, and a 101 millihenry inductors. There's that opto isolator, but the opto interrupter that goes to this piece. So you could always just take that thing off, and then there's a nice header right there. You can just unsolder. At the end of the board here, we have a bunch of nice connectors for CF cards and SD cards and such. And I'm guessing on this, and it looks like this, the CPU is, well, they covered it up so you can't easily see what it is. My guess is it's probably another ARM CPU. Those things are just awesome and easy and ubiquitous. Memory chip as well by Hynix. Bet you if you actually use a memory reader, you could probably read what's off of that, or it may be RAM. Not sure. There's another chip over here. Lots of little parts on here you can play around with. And of course, look the part numbers up on Google, wherever, part searches, and you can then unsolder them and use them in your own projects as you see fit. Now, one last thing before we go. I'm seeing a 3-pin header going somewhere. What does it go to, and how do we get it? We're just going to do the old-fashioned way of pry and pull. Probably not the best thing to do, but you know. Okay, what is this? What is this thing? Goes into a nice wiring harness. Looks like the 3-pin something. I usually know that the opto interrupters are 3-pin. And that's kind of what it appears to be. So we go ahead and break this thing apart. Since we know we aren't putting it back together, I can go ahead and pry plastic junks out of the way. Plastic there was to retain the cord and make sure they didn't get bound inside the printer unit. Okay. And it looks like this is a really, really nice headered opto interrupter. And it looks like this is for another one that was being used for paper feeding, and it's got a little rocker binary switch right here where it's just a big fat instead of a bunch of little lines. Looks like there's also lots of gears over on this side. Not sure how they work, but I'm sure they work somehow. But this electronic is great because we can actually use that big opto interrupter line and interface right to it. And this is easy to use with the Arduino. Ideally, if you hook it up to an interrupt on the Arduino and make it so it's binary logic, you can watch a DC motor spin as it goes and then stop it almost instantaneously. Obviously, you want to profile it to make sure that see how fast it goes after you cut power to it. And there's another spring that just flew away. Okay, so this gearing train here looks like it's two separate gearing systems here. Looks like there's one for this roller, and it's a movable roller, pretty nice, and then there's one for over here. Now, unfortunately, it looks like that's completely fixed into the metal or the plastic casing on this. So ideally, we probably want to keep this until we can migrate out of these gears to something else. So, what else we got here? A few more screws. Even though I don't like them, we'll save them. What else we have? Okay. Paper selector size. Nothing fancy. As you can see, we've pretty much stripped it. There's a little bit more over here for the ink, but I really don't want to get any more ink on me. Okay, so it looks like this teardown is done. Got a nice bit of pull here. And we'll go over, as a recap, I'm not sure what to do with these. This one looked like it broke, so junk for the time being until I can figure out how to recycle them and who will take them. Okay, so obviously we have screws. We have possibly broken, not possibly, they're broken, but they have gears in them that aren't broken, so we can harvest the gears out of them. We have this wonderful gearing system right here with a nice DC motor on it with a ferrite bead on it. And this is really nice system here. We have another roller with another optical, this doesn't have optical, it has nice gear on it, cool. We have a belt, which fits this motor, awesome. We have this wonderful smooth rod that has two retaining clips on the end, so you could easily affix this to your project. We have two springs. They're not fancy, but you never know when you need them. Ribbon cable. CPU board with a lot of nice little components you can just fry off the solder and pull the parts out. They're always useful that way. Or if you had an interface with it, all the better. I'm still learning. Two ferrite cores. A really interesting white light scanner with the wiring harness as well. An opto, the optical interrupter, and a nice wiring harness with buttons, and the LCD screen, and more buttons. And of course this thing, we'll have to figure out how we want to take this apart. Eventually the gears will go away, or I'll put them into my gear bucket. Awesome bucket, by the way. But yeah, this is what a pull you can get from a printer, and this is all the usable parts. And obviously, using DC motors, stepper motors, you can do lots of things with these. And also, how much is this motor? This is a C9000-6005. Let's go ahead and search this right now. You never know what you're going to get here. I'm guessing it's a 12 volt, but you know, I could be and am probably wrong. So let's look up motor space C9000-60005. Let's see what it gets. And nothing. Unfortunately, we're still moving the hackerspace into the new place here, so our internet isn't completely set up. Pity. But regardless, you can do the Google search on your own. I would probably rate this motor as a $5 motor, if not more, with a pulley. So you get the idea. I can reduce bills of materials down very significantly, which this does very directly go back to my project, the 3D scanner, in which most of my stuff was reclaimed. But this is how I reduce my costs, given a bit of time and junk. Thank you again for listening to me ramble and rant about how to help make your own projects, and also a little bit of my own. Have a great day.